volumes, class 9. So as we already have learned first two exercises about all of those, um, today we are going to uh, today we are going to continue with our surface areas and volumes. Third 13.4. I'm just going to present without any further delay. Let us start. 13.2 is very easy exercise. We have stopped it in middle, but it is very easy. Okay, so let's start reading and understand. So far, we have been generating solids by stacking up congruent figures. Incidentally, such figures are called prisms. Now, let us look another kind of solid which is not a prism. These kinds of solids are called pyramids. Let us see how can we generate them. Cut out a right angle triangle ABC right angled at B. Place a long thick string along one of its perpendicular sides, say AB of triangle. Hold the string with your hands on the either sides of the triangles and rotate the triangle about the string of the number of times. What happens? Do you recognize the shape that the triangle is forming as it rotates from around the string? Does it remind you of the time you had eaten an ice cream heaped into a container of that shape? This is called right circular cone. In figure 13.13 C1 of the right circular cone, the point A is called the vertex, AB is called the height, BC is called the radius, and AC is said to be the slant height. Here B will be the center of the circular base of the cone. The height, radius, and the slant height of the cone are usually denoted by HRL respectively. Once again, let us see what kind of cone we cannot call a right circular cone. Here you are. What you see in these figures are not right circular cones because in the line joining its vertex to the center of its base is not a right angle to the base, and in B the base is not circular. As in the case the cylinder, since we will be studying only about the right circular cones, remember that by the cone in this chapter we shall mean right circular cone. There is an activity given. You can do that. Cut out a neatly made paper cone that does not have any overlapped paper straight along its side and opening it out to see the shape of the paper that forms the surface of cone. It looks like a big part of a round cake. If you now bring the sides marked A, B at the tips together, you can see that the curved portion will form the circular base of the cone. Of the paper like one is figure 13.5c. Now cut it into hundreds of little pieces along the line drawn from point O. Each cut portion is almost small triangle whose hand is a slant head of the cone. Now the area of a rectangle, each triangle equals to half into base of each triangle into length. I mean slant height. Sorry. So area of entire area of piece of paper equals the sum of all the triangles. So curved surface area of cone is pi r l. It is pi r l. To find the L, that is slant height, we have to do root r square comma h square. This is a form curved surface area of a cone. To find the lateral surface area, L equals to r square plus h square. Clear? Now the total surface area of cone is pi r L plus r. Okay, pi r into slant height plus the radius. Clear, guys? Pi r into L plus r. Pi r, pi, pi r into L plus r. What all we learned from the first? Just let's revise. The curved surface area of a square is 4a square. Total surface is 6a square. 2h into L plus P is the curved surface area of a cuboid. Then it is 2 into LB plus BH plus HL is the curved total surface area of a cuboid. Then coming to cylinder, uh, 2 pi r h is the curved surface area. 2 pi r into r plus h is the total surface area. Here pi r h is the curved surface area. Pi r into r plus L is a total surface area. H is not the slant height here. Okay. So let's go with our example 4. What does example 4 say? Example 4 saying, find the curved surface area of a right circular cone whose slant height is 10 centimeter and the base radius is 7. So they said curved surface area. Curved surface area of a cone is pi RL. Here we know pi value. R radius is given as 7 centimeters. Slant height is given as 10 centimeters. So 22 by 7 into radius is 7 into 10. 7 7 cancel. 22 tens are 220 centimeter square. Will be our answer for example 4. Going with the example 5. What is example 5? The height of a cone is 16 centimeter and its base radius is 12 centimeter. Find the curved surface area and the total surface area of the cone. Here the height is being described as slant height, which is 16 centimeters. The radius is 12 centimeters. CSA, we know what is CSA? Pi RL. Pi RH, pi RL. Okay. So pi here is 22 by 7. R is 12 and into 16, which will be equals to nearly 753.6 centimeters square. Now what you have to do? Total surface area pi r into L plus r. Right. So pi 22 by 7 into r here is 12. Is it 12? Yes. Into L here is 16 plus 12. Then the answer will be, what will be our answer? 1205 1205.76 centimeter square will be our total surface area. Clear? Now going with our example 6. What does our example 6 say? A corn cob shaped somewhat like a cone has a radius of its broadest end at 2.1 centimeter and length as 20 centimeter. If each 1 centimeter square of the surface of the cob carries an average of 4 grains, find how many grains would entire cob require. Here what are they talking about? 1 centimeter square, it is 4. Then how many will be for the total? That means total area we should find first. The corn cob shaped somewhat like a cone has a radius of its broadcast and the length. Here they are not talking specifically about particular one, right? They are not talking. Just a second. Okay, so guys, something we have missed in example 5, that is here they did not give us lateral, sorry. Here what did they didn't give us? They didn't give us a slant height. They gave us a normal height. So to find the slant height, we know L equals to root r square plus h square. So r here is 12 square plus h is 16 square. Then the answer would be 20. So 20 centimeter you have to use in place of 16. Clear, guys? Then 20. So you're going to answer. Going with our example 6, what does our example 6 say? Since the grains of a corn are found only by on the curved surface area of the cone cope, we could not need to know the curved surface area of cone cope to find the total. In this question, we are given the height of the cone, so we need to find its slant height. So same way they have given the height. So slant height is L equals to root r square plus h square. L equals to R here is radius is 2.21 square. Height here is 20 square. So you will get the answer as 20.1111 centimeters. So this will be our lateral, slant height. It will be a slant height. Now, as the corn, whenever we eat corn, we observe that the grains, whatever grains will be, that means this is a corn, right? So the grains, whatever grains will be, it will be on the side only. It doesn't be on the down or up, right? It will be only, it is coverings of side. For example, I took a pen. It will only be at the side. It won't be at the top nor bottom, right? So this is what a cone actually uh, cu- curved surface area actually mean, right? Curved surface area means what, guys? The leaving the top and the bottom only the coverings of all the other sides. Okay, so this is what curved surface area means. So here we are observing the same. The grains are only covering the sides, they are not covering the top and bottom. So what we will take? Curved surface area of the particular one. CSA is, what is the CSA of this one? Pi RL. Pi is 22 by 7. R is 2.1 into 20.11 centimeter. Then you get the answer as 132.73 centimeter square. Now what we have learned, 1 centimeter square is 4. That means 1 centimeter square is 4. Then how much will 132.73 will be? 4 into 132.73. Then the answer will be 4 into 132.73. Answer will be how much? 531 approximately. Then this will be our answer. That means 531 grains will be over there. Fine. Going with our 13.3 exercise. Let's start doing with our 13.3. Only 8 problems are there. We'll complete it soon. Going with our first problem. What does our first problem say? Diameter of the base of a cone is 10.5 centimeter. Here diameter they are talking about. Diameter is 10.5 and the slant height is 10 centimeter. CSA they are asking us to find. Of course the radius will be how much? 10.5 by 2. Let's take this one only. Not required to change, guys. Don't change. Okay. So 22 by 7 into radius here they are talking 10.5 by 2 into 10. That is 1 and 5. So 22 by 7 into 10.5 into 5. Clear? Now when we substitute, how much will we get answer? Let's try to do this without any dependency. So 7 ones are 8, 9, 10, 35, 5. 1.5. 1.5. So 22 into 5. 5 twos are 10. 5 twos are 10. 11 into 1.5. 1, 10 to 15. 0, 5, 5, 0, 1, 0, 1, 1, 1, 1. 0, 5, 6, 1, 165, I think is the answer. Okay, let's search centimeter square, meter square. Centimeter square is our answer. First question of our 13.3. Yeah, 165 centimeter square. Going with the second one. Here the total surface area of a cone. Find the total surface area. TSA of a cone is pi r into r plus L. This is what is na? Very good, right? If the slant height L is 21 meter and diameter is 24 meter, that means radius is 24 by 2, we get 1 to 12 centimeter, 12 meter. Okay, now let's find 22 by 7 into radius here is 12, right? Into r here is 12 plus 21. 22 by 7 into 12 into 3, 3. Okay. So when we substitute 22 into 12, 264, when we substitute this 264 into 33, 15, 16, 17, 20, 29, 30, 31, 32, 31, 32 point. Let's check the answer. How much is it right? No. Yes, it is right. 1244.57 meter square is the right answer. I got that one only. Okay, you approximately can write 1244.60 meter square approx, and you can mention it as approx. Third one, CSA of a cone. Here the total CSA is being talked about is 308 centimeter square. If slant height is 14 centimeter. Now they're asking to find the radius of the base and the total surface area of the cone. So we know the formula of the curved surface area is pi RL, except R everything is given, so we can find it. 22 by 7 into R into 14 equals to 308. So 7 to 44 R equals to 308. So R equals to 308 by 44. 22 um 5 4 11 7 67 11 7. So the radius is 7 centimeter or meter, guys? Centimeter. Clear? Going with the second question. What is the second question asking? Total surface area. Total surface area pi r into r plus r. So pi is 22 by 7. R is 7. Lateral surface area, sorry, slant height is 14 plus 7. 7 7 cancel. 22 into um 8 9 10 11 21. 22 into 21. 462 centimeters square is a total surface area. Clear? I'm not sure about the total surface area, but I'm sure about the height, slant height. So yes, it's right. Going with our fourth question. What does our fourth question say? A conical tent is 10-meter height and the radius base is 24 meter. The base radius is 24 meter. Height is 10 meter. They're asking us to find the slant height. So L equals to root r square plus h square. Obviously, yes. So L equals to r here is 24 square plus h is 10 square. So let's solve this. 100 plus 24 into 24. For 4 is a 16, for 2 is a 8, 9, 0 to 4 is a 8, to 2 is a 4, 6, 17, 576 plus 100. 6, 7, 67. So laterals of, sorry, slant height is 6, root 676. So it will be, So around 25 it will be. Just a second, I'll just find out. Maybe 26. Yes, 26. So slant height is 26. Okay, so now we have find the slant height of the tent. Now what are they asking in the second question? Cost of canvas required to make tent. If 1 meter square, here they're talking about here, let us here what we have find slant height, right? So if 1 meter square is 70, then now we have to find what? We have to um, find the total surface area, TSA is, because it didn't mention only up or down or all those things. Okay, so it will be how much? Pi r into L plus r, 22 by 7 into radius here is 24 into 26 plus 24. Senate 1950. So, guys, just a second. Okay, let's find it out. 22, 24, 4 to 8, 8, 0, 4, 4, 8, 9, 10, 11, 12, 5, 28, 50. 7 3 is 12, 7, sorry, 7, sorry guys. 7 3 is 21, 5, 0, 0, 3, 8, 0, 0. So, it will be, let me check the answer. No, it isn't right. Okay, just a second. Let me check with this one. Here, 20. 6, 7. Uh, so guys, we will do the fourth one, second one later. Let's leave that because it's taking a lot of time. Let's go with our fifth question. What does fifth question say? What length of tarpaulin 3 meter wide will be required to make a conical tent of height 8 meter? Here height is 8 meter, radius is 6 meter. What are they saying here? Assume that the extra length will be required for stitching margins and wastage in cutting approximately 20 centimeters. So how much we got? We have to remove 20 centimeters, and for the 3 meter wide one we should do this. Yeah. Yeah, guys. So we will end up this video here and go with the next later on and continue with the next problem. So hope you all will take care.